I made a video before on this channel about how I'm leaving academia, and in that video I discussed my master's, I did my research in theoretical computer science. Today I want to talk a little bit more about math, because in undergrad I did 2 degrees. I did a major in computer science, but I also majored in pure mathematics. And the thesis of this video, what I want to try to convince young, smart people to do, is to take some pure math courses in undergrad. Not applied math, pure math. And there's a specific reason for that, which is this magical word that math professors and math students use called mathematical maturity. Anybody who's done math in university knows what I'm talking about. I mean pure math. Mathematical maturity is hard to define, but there's some point in the journey of an undergraduate math student at which point they're able to reason, to abstract, to learn new things on their own, to not have their hand held in tackling new concepts, new definitions, new conceptualizations, and actually being able to formulate and structure new definitions and meanings. Now you'll notice like how I just described it in these 2 sentences isn't very specific to math. This is like a theoretical intellectual skill set that's important for approaching anything. And therein is the magic of doing a math degree or even just some pure math courses, enough to gain mathematical maturity. That's what you need to do, take enough pure math courses to gain mathematical maturity. Why? Because once you do that, you're going to be able to learn anything. There was a moment where I know where I gained mathematical maturity. It was in my 2nd year, in my 2nd semester at university. I took MAT 257. Those who know. That's probably one of the hardest undergraduate courses in North America, or so it was told at the University of Toronto. This is analysis 2. You get to stuff like Stokes theorems and differentials. It's basically multivariable analysis from a very theoretical, abstract perspective. And it was tough. I suffered. I think of myself as a pretty smart guy. I was far from the smartest person in the room. And I didn't get the grade that I wanted. I struggled all throughout that course. But what I did get was invaluable, was very rich, was I really felt by the end of that course that I could go and learn anything. If I struggled through this, no realm of human knowledge or skill set was now beyond my reach from an intellectual perspective. When you go to like an amusement park, like Canada's Wonderland or something, I used to be scared of roller coasters. So my strategy was I would go on the biggest, baddest roller coaster right in the beginning, force myself to do it, and when I conquered that, the Leviathan as they have it in Canada's Wonderland, every other roller coaster looks easy. You do the hardest thing, and you gain the confidence to conquer everything else. And math is like that when it comes to cognitive accomplishments. When you do math, you really build confidence in your ability to gain, to succeed in any cognitive task, any intellectual task. Like I told you guys, I was mainly a computer science person, and most computer science people took a very negative mindset towards math. Oh, I hate math, I'm not good at math, math sucks, math is not important to doing what I want to do. Yeah, you need to grow up. Because math is just abstract reasoning. It might not be your strength, it doesn't have to be your strength. But you need to, approach it with a seriousness and respect, because it can do lots of things for you. And lots of these, the people that you look up to, your heroes, like Bill Gates and Mark Zuckerberg, were math geniuses. And they would have succeeded as well at theoretical computer science. Just as Bill Gates, famously in undergrad, he improved an algorithm, I forget which algorithm, some pancake sort or something like that, as they would have at business and in their entrepreneurial endeavors. So it is really important to take the right mindset towards it, because if you take the wrong mindset towards it, anything will be hard. But I think that even though I'm not in that field anymore, I don't do research anymore, I still benefit from the core competencies that math gives you which is being able to define a problem domain. Before you even define the problem, to what domain does this problem exist in? And then being able to define your terms in very specific ways. You know, I remember in my first year math course, like we learned the epsilon delta definition of a limit. You know, for every epsilon greater than 0, there exists a delta greater than 0, such that if x is a delta distance from the point in which we're taking the limit towards, then the function value at x is within an epsilon distance of the limit value. I know that probably means nothing to anybody who hasn't taken first year pure math. But when they taught us that definition, it was Greek to me. Literally, that's Greek letters, right? It's a little joke. But it was hard for me to understand, but the way they got you to understand the definition was pretty brilliant. So they gave us a worksheet where they gave us 10 different versions of that definition. Each one of them changed one term of the definition. I just gave you a very long definition. They changed one term of the epsilon delta definition in each term, and they told us, okay, what does it mean now? What does it mean now? What is it saying now? And each time you change it, you know, it might be a subtle change, it might have a big impact on the definition. So it taught you the subtlety of how definitions can change how we think on the conclusions that we're making. And you could immediately see the importance that this has in intellectual discourse, in communication, in solving problems, both engineering kinds of problems and human kind of problems, and just being able to engage with ideas in general. And then, okay, another core competency beyond the definition and the problem domain is the problem-solving techniques themselves. Like, you know, you learn proof by induction, you learn, you know, structural induction, hard induction, weak induction, you learn, or strong induction, not hard induction. You know, you learn proof by contradiction, you learn, you know, the contrapositive, and these are powerful ways you can manipulate logical predicates to look at a problem in a different way. To solve easier versions of a problem. You know, it's like, you know, when you go to the gym, you might go to a machine that just like laser focuses on a specific muscle group. You know, you can get stronger just by cutting down trees, like a lumberjack, but are you going to be able to like laser focus on and surgically, you know, improve your strength in specific areas that just cutting down trees, you know, would take you forever to do? And that's what math does to your brain when it comes to problem solving. And so I do really believe in its strength, and that people who are smart in other areas, maybe you're very smart linguistically speaking, maybe you're very smart at engineering or whatever it is, you should supplement your skills with math. And I'm especially, because this is a Muslim channel, I'm especially evangelizing this to Muslim youngsters. Because when you're, again, it's going to give you the confidence to be able to approach any cognitive task. Nothing is going to feel like, well, this is too hard for me. Because there's nothing really harder from just an intellectual abstraction point of view than math. Sorry to say to all my physicist friends, to all my engineering friends, it just really is the final boss when it comes to cognitive tasks. Unfortunately, as I spoke about in my previous video, it's in Muslim culture, we're usually pushed to go do engineering or medicine, something more applied, you know, something super theoretical like math, pure math. You know, maybe some families would be okay with that, but I think most parents, if a young Muslim wanted to do that, you know, it would be looked at as something weird at the very least. That's why, you know, usually pure math is filled with white people and Jews and Chinese people, not so much Muslims. Definitely engineering is to the brim with Muslims. You know, hands down, kudos to the Muslim community. We have that one on lock. But I really want to just push the lever a little bit on the pure math side of things, on the theoretical side of things, so that we can become, because a math person can become a real strong thinker. Wa alaikum assalam wa rahmatullahi wa barakatuh.